Audio slate.
Bob Leinss, December 20th, 1988. Interview. Good afternoon. Welcome to this week's edition of Medicine of Today. My guest today is Bob Leinss, who is a pharmacist, and we're going to be talking about the changing fields of pharmacy. Welcome.
Thank you.
I first want to ask you, how did you decide pharmacy was the career you wanted?
Well, I always enjoyed math in school and chemistry, and actually liked science a lot, and got a job as a part-time stockkeeper in a pharmacy when I was younger, and so decided when I went on to college that that was something I'd like to go into. Mm-hmm. In fact, I had my first calculus class in college and realized that I wasn't going to make it in math, so at that time I decided that pharmacy was probably the way to go. So.
I see. What developments have you seen in this field in the last 5 years?
Pharmacy is a profession that's been in transition for a long, long time, and it's still in transition. The advent of women in pharmacy has been increasing dramatically in the last 5 to 10 years. In fact, over 60% of the graduates from the schools today are women. It's an excellent part-time job for women after they have children and get married. That also is leading to another problem in pharmacy today, which is a shortage of pharmacists. Other changes that have occurred are the competitiveness of the field. There's a lot of different types of stores out there. There's drugstores now and supermarket, food stores, discounters, department stores. So the competition has really increased. And probably, thirdly, the biggest change is the advent of generic drugs. The number of generic drugs that are out there today are a lot more than there were, say, 10 years ago.
I see. Is there any difference between the generic drugs and the brand name drugs?
Not really. The FDA has a means of testing drugs to assure that they are what they call bioequivalent, so that when they are taken internally, they dissolve and really provide the same amount of drug to your system as the brand name would. The difference lies in the way a manufacturer might put a tablet or a capsule together, in that one might dissolve a little bit faster than another and lead to different blood levels, and that can sometimes change the effects of a drug in particular people. But basically, a generic drug by a well-established manufacturer is going to be just as effective as a brand-name medication.
I see. Why is it that the newly introduced drugs are expensive?
Any manufacturer that comes out with a new drug has a 17-year patent on that drug. And many times the patent is taken out at the initial stages of development, so that before that drug reaches the marketplace, it may have half of its patent already expired. It may have 9 years left once the drug reaches the market. And so to recoup the enormous upfront expense of research and development, companies put a big price tag on that drug. And some just cost more due to the type of medication that it is. But basically they're trying to recoup the investment of all the research and development in that drug. Plus, with the advent of, as I mentioned, generic medications, as soon as that patent goes off, anybody can make that medication and start charging whatever they want for it. So the competition really heats up. So the manufacturer that really initiated that drug wants to get as much as they can for it at the time that it's brought to the market.
Interesting. What do you feel has been the biggest breakthrough since you've been a pharmacist? Probably
the increase in the number of drugs that they can now formulate just due to biogenetic engineering, where they can actually take genes or program a bacteria to create a certain type of medication. For example, human insulin wasn't available 5-6 years ago. We used to get insulin from pork, pigs, or from cows, beef, and it was actually extracted from the dead type animal.
Really?
And today they can actually biogenetically engineer human insulin from amino acids and put that together. So that opens up a whole wide range of types of things that can be brought to the market.
What did you, before we were talking, you said something about gene splicing. Mm-hmm. Can you explain that a little bit?
That's basically where they take a bacterium and program it to actually put together a type of compound, and they can actually put a program basically inside of a bacteria that says make this sort of medication based on certain genes that are put together, and allow them to do that so that it can be in its purest form and not really have to be synthesized as it does today from maybe some plant compounds or natural resources, but really put together from nothing.
All right. Okay. That's really interesting now that all goes. But It's been great having you here today, and tune in next week for Medicine of Today.
Thank you.